meet Gaurav. He's quite happy today. His investment in Lido Bank is maturing next month and he's expecting a huge amount. Do you want to know how this happened? Gaurav invested 1000 rupees in Lido Bank, which offers compound interest at the rate of 10% per annum. At the end of the first year, his investment has increased to 1100 rupees. Wow, the original sum of money has increased by 100 rupees in interest. And since Lido Bank offers compound interest, the principal for the second year doesn't remain 1000 rupees. It becomes 1100 rupees. The interest for the second year is calculated on this new principal and Gaurav got 110 rupees, giving him 1210 rupees at the end of the second year. Isn't it so fascinating to see how the power of compound interest increases year after year? But what if Gaurav invests his money, that is the principal, for 10 years or more? Do we keep calculating the amount year after year? Or can we do it in a shorter way, like we do it for simple interest? Let's look at Gaurav's money in Lido Bank, but a little differently this time. In the first year, the principal of 1000 rupees increased to 1100 rupees. But let's just keep the principal and interest separate for now. You will see why. The principal is 1000 and the interest is 1000 times 10 divided by 100. We add these and we get the amount which is equal to this. Now in these two terms, we can take out 1000 as the common factor, which leaves us with 1000 times 1 plus 10 over 100. Since the interest gets compounded, the amount at the end of the first year becomes the principal for the second year. So this amount becomes Gaurav's new principal. Let's look at what happens in the second year. We have the principal as 1000 times 1 plus 10 over 100 and the rate as 10%. So the interest will be this quantity times 10 divided by 100. Add that to the principal, we get this as the expression. Again, we can take out the principal, which is this expression, so we are left with 1 plus 10 over 100 in brackets. Since we are multiplying 1 plus 10 over 100 into itself, we can use exponents to represent it. So this becomes 1 plus 10 over 100 whole squared. This amount becomes the principal for the third year and the same routine repeats. Do you see a pattern here? After 2 years, the expression of the amount has 2 in the exponent. After 3 years, it has 3 in the exponent. And if we look back at the expression for the amount after 1 year, we can also write it as 1000 times 1 plus 10 over 100 raised to the power 1. So the amount at the end of n years can be written as 1000 times 1 plus 10 over 100 raised to the power n. The rest can be generalized. We can write the principal as p in place of 1000 and the rate as r in place of 10. So we can derive the amount after n years by using this formula. A is equal to p times 1 plus r over 100 raised to the power n. Now Gaurav has to find the amount after 10 years if he decides to put 1000 rupees in Lido Bank. It's very simple. He only has to substitute the values of principal, rate of interest and period to calculate the amount. The amount is 2594 rupees. Isn't it great? This formula can help us calculate the amount after any number of years and save us from repeated calculations.